Hello everyone. Uh, in these previous videos, I described so many things like determinant, transpose, okay, trace of the matrix, and adjoint of the matrix, and also inverse of the matrix. Okay, so now I also describe the range and echelon form. So now I describe some important. Okay, so focus here. So now I describe the system of the linear equations. Okay, system of the linear equations. Okay, so these are means two. They are two system of the linear equations. First is homogeneous linear equation, and next is non-homogeneous linear equation. So first is homogeneous linear equation. Okay, so it is ax is equal to 0. Okay, and second is non-homogeneous linear equation. Okay, so I think it is better. Okay, now it's okay. So there are two types. Okay, homogeneous and non-homogeneous. So first I describe about the homogeneous. Okay, homogeneous linear equation. Okay, so I also told you about the matrix. So I can write a11 x1 and a12 x2. Okay, plus till a1 n. Okay, so because it is increasing, it is first row, so first, and this is the n column, and x n, so it is equal to 0. Same thing is here, a21 x1 plus a22 x2. Same thing happen, so a2n xn is equal to 0. Okay, so same thing happen, and I can write here a m1 x1, okay, plus a m2 x2. So a m n x n is equal to 0. So it is a homogeneous equation. Okay, so it is in the form of ax is equal to 0. So you can see here that ax is equal to 0. Okay, so I can write it in a matrix like a11 a1 to till a1n. Okay, so a21, a22 till a2n. Okay, so same thing, am1, an2, amn. Okay, so it is in the order of m and n. Okay, so after that, it is, I say that it is, this is a. Okay, so now I need to write x. So how I can x, so it is means multiplication, so I can write x1. Okay, x2, x3, dot 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 dot, xn. Okay, like if I multiply this by this, so this term is come. After that I multiply this and this, so this term, and same thing is happen till a1n into xn. Okay, so it is in the form of, in the order of n into 1. Okay, so is equal to 0. Okay, so this term is known as the coefficient matrix. Okay, so please note something I write here. Okay, so first point is number of the linearly independent infinite solutions of m homogeneous linear equation in a variable. Okay, so it is ax is equal to 0. Okay, is n minus r, where r is rank of the matrix A. Okay, so first point, and next point is homogeneous system of equations are always consistent. Okay, so point third is, if r is equal to n. Okay, so then the equation ax is equal to 0 will have only the trial unique table unique solution x is equal to 0 comma 0 comma 0, like, okay, and it is g. So I can, it is right as consistent unique solution. Okay, so point 4, if r if r is less than n so then we have we have n minus r linear dependent linearly independent non trivial infinite solution. Okay, so I can write here, if r is less than n, so it is 0. Okay, so like that is a is a single matrix. Okay, so this is for the homogeneous linear equations. So there is another second term is non-homogeneous linear equation. So for non-homogeneous, ax does not is equal to 0. Okay, so see here, non-homogeneous linear equation. Okay, so I can write as ax is equal to b. That's mean ax does not is equal to 0. Okay, so I can make a matrix by using the previous statement from this statement. Okay, so now what, in the non-homogeneous these are not is equal to 0, so something I do here, so a11 a12 it is tell a1 n. Okay, a21 a22 it is still a2n, so it will happen am1 am2 it is still amn. Okay, so it is the in the order of m and n, same like previous, and there is another matrix which is in the term of n into 1. So what is this? This is x1 x2 xa xn till xn. Okay, and it is now it is equal to v1 v2 v3 till vn. So, and it the order of that is also n into 1. Okay, so you can see here the difference between the homogeneous and non-homogeneous is that in this matrix it is does not is equal to 0. We take a matrix and v matrix, and here this is equal to 0. Okay, so it is the main difference between the homogeneous and the non-homogeneous. So now the matrix AB, now the matrix AB is like it is an equation, so then I can take these here, like a11, a12, it is still a1n, a21, a22, a2n, so it is still am1, am2, amn. Okay, and here v1, v2 till vn. Okay, so it is still bn. So now this matrix, is known as augmented matrix of given system of equation. Okay, so there are some condition for non-homogeneous. So after that we discuss on the eigenvalue. So first take some conditions. Okay, conditions of consistency. Okay, so I can write here, like first is if r a, you know, r is the range of the matrix A, does not is equal to the range of a by b. Okay, so no solution system is inconsistent. Okay, so second point is if range of a matrix it is equal to r of a by b. Okay, so it is equal to r, it is equal to n. Okay, so it is a consistent unique solution. And the last point of this topic is if a rank of a matrix is equal to rank of a by b, then it is equal to r. Okay, if r is less than n, so then constant infinite number of the solution. Okay, so I hope this is very theoretical topic, so I think it is boring, so but it is also need to remember, so you can note these things. Now next video I discuss about the eigenvalue and the eigenvector. Okay, so thank you.